looking at section 2.1 continued, or part 2, continuing with our relations and our functions. So a function rule is an equation that represents an output value in terms of an input value written in function notation. So a function rule, anytime you see the word rule is always going to mean that you're dealing with some sort of equation. Now it represents some output values and some input values. We're going to talk about that in a moment. So the next part talks about an independent variable, which is x, which represents the input of the function. So our input value, they just said our input is our independent, is our input, which is our x value. And then it says that our dependent function, they call that f of x. F of x is also considered to be the y value, is going to be an output of the functions. It says it is the dependent variable because its value depends on the input value. So now we have a little bit more to add on to that chart that we started on the front of our packet. So we have some new words. We have input and output, and we have independent variable and dependent variable. So if you just flip back to the front of your packet, back where we started our x and y, we had our domain and our range. We're now going to include an input and an output. We're going to include independent, and we are going to include dependent. Now, this is a review of Algebra 1. When I teach at Algebra 1, some main ways to help you remember. In terms of x and y, they're alphabetical. X comes before y. Just like x comes before y in the alphabet, domain comes before range. And I comes before O. So input and output, right? Those are alphabetical. Now that does not work with our independent and our dependent, but if you think about the fact that our input is independent, those go together. So alphabetically, domain and range, input and output. The independent goes with the input, and the output is what is dependent. If that helps you remember it. If not, find your own way to kind of keep track of what those are. So, all right, so we added a couple things onto our list. So they also call the dependent variable an f of x. F of x, that is what that function notation is. F of x, what they talk about with the function rule, the function notation. Again, you would have learned about that in Algebra 1. So example 5, using some function notation. Ooh, looks like my notes got a little cut off. So yours should say for f of x is equal to negative 3x plus 2. It says what is the output for the input, and then they have a negative 4, 0, and a 0.2. So mine got a little bit cut off, I think because I typed in an equation and it just didn't transfer. That's okay. You have it in front of you anyway. So we have a function rule, our f of x equals negative 3x plus 2, and they want to know what is the output when we have input values. Now remember, we said input values, those are going to be x values. So that means we are going to plug in for x, negative 4, 0, and 0.2. Now I think the easiest way to organize information in this case would be to make a table. So we're going to have our x values. We're going to have our f of x column is equal to negative 3x plus 2, kind of like that process column that we did back in chapter 1. And then we'll have our output values. Now, I'm just going to write the word output so you understand that that's what we're looking for in terms of our f of x. And our x is our input, right? We input x, we output f of x, the function evaluated at that value for x. So we are going to plug in a negative 4, we're going to plug in a 0, and we're going to plug in a 0.2 and do a little bit of math. So our f of x, the value of our function at negative 4, is equal to negative 3 times negative 4 plus 2. So all I'm really doing is evaluating what this is. A negative 3 times a negative 4 would give us a positive 12, and then when we add 2, we end up at 14. If I plug in 0, what's the value of our function at 0? So negative 3 times 0 plus 2. Well, anything times 0 is 0, plus 2 gives us 2. And then what is the value of our function at 0.2? We'd have negative 3 times 0.2, and then we would add 2 to that. So negative 3 times a 0.2 would be a negative 0.6. Negative 0.6 with a positive 2, that would give us a positive 1.4. Just some mental math. Throw it in the calculator if you need. So it says to model real-world situations using a function rule, you need to identify the dependent and independent quantities. It says one way to describe the dependence of a variable quantity is to use the phrase such as distance is a function of time. This means that distance depends on time. Anytime I break this down, especially every time I teach it from the get-go, the first time you would have seen this, the word is tells us we have equals. So in general, distance is going to be our output value or y value or an f of x value. Is means equals a function of time. That means something going on with our x. So I'll say something going on with x, with our input value. So something is a function of something else. A distance is a function of time. Y is equal to something going on with x. Or maybe you had d for distance is equal to something going on with time t. Your variables may change depending on the situation. So example 6. This is writing and evaluating a function. It says that a pizza costs $14. It says the flat delivery fee is $1.50. What function rule models the total cost of the number of pizzas delivered? And then it says to evaluate for 5 pizzas. So first thing we need to do is we need to write a function rule. What function rule? What does that mean? That means write out an equation. EQN is a way that I will abbreviate equation. So a pizza costs $14. That means each pizza is going to cost $14. That means 14 is going to multiply by the number of pizzas, which means we need a variable for pizzas. So maybe we want to say P, the pizza are going to be the number of pizzas. So pick a variable. If you want to use X, you can use X. We have a flat delivery fee of $1.50. So write a function rule that models the total cost of the number of pizzas delivered. So the total cost is a function of the number of pizzas delivered. So that means we need a variable to represent total cost. So maybe we use C of P, the cost in regards to the pizzas. So the cost of P pizzas. So let's see. The cost in regards to our pizzas, the cost of our pizzas is equal to, well, what do we know? Each pizza is going to be $14, and we have to add $1.50 to have it delivered. So we're going to have 14 times the number of pizzas plus the flat rate of $1.50. And then they want you to evaluate for 5 pizzas. So that just means plug in 5 where we see P. The cost of 5 pizzas is 14 times 5 plus $1.50. So if I took 14 times 5, that would give me 70 plus, that should be $1.50, plus $1.50. We should end up with $71.50.